Hi, welcome back to the Math Lounge. So what we're going to be doing now is we're going to go over two more topics, distance and spheres. So we'll do those in separate videos though. So distance, you know the distance formula, don't you? In 3 dimensions, it's the same exact formula. In fact, in fact, here it is. And we're going to use this absolute value symbol sort of to indicate distance, but it's really not that bad. So you're already familiar with this idea. In fact, let me remind you in case you're thinking, wait a minute, I don't remember this stuff. Here, why don't I just put this up here and remind you that if you want to find the distance between 2 points, distance is equal to the square root of delta x squared plus delta y squared. So here's delta x, and this is delta y. And so you can imagine this is basically related to the Pythagorean theorem. Now, once you throw in a third dimension, you just have a delta, whoops, not another delta y, you have a delta z. So that's what that third thing is up, whoops, up here, yeah, up there, is you'll see the z2 minus z1 squared. So really not that difficult to execute this. In fact, let's go ahead and do this. Let's consider this point. Let's see, so I have P is the point 3, 1, and 8. And we're going to go through each of these relatively slowly. Let's see, we have A. A is the distance from this point to the xy plane. Now that one's easy because the distance from this point to the xy plane is just the z value. So that's just 8. What about the distance from this point to the xz plane? Well, that's just going to be the y value. And same thing goes with the distance from this point to the yz plane. That distance is just the x value. So parts A, B, and C, you just have the z value, the y value, and the x value. So that's not bad. Okay, what about the distance from this point to the x-axis? Well, the point that is closest to this point on the x-axis would be this point. Whoa, no, I don't want to name it. I was just going to do this. So the x-axis is the place where y and z are both 0. So on my little model here, the x-axis pointing down and to the left, all of the points on that axis have a z value of 0 and a y value of 0. That's what makes it the x-axis. So anyway, the point that is closest to 3, 1, 8 on the x-axis would be 3, 0, 0. And if I want to know the distance between these 2 points, I would do the square root. Here, I'll do this over here. This is letter D. It's going to be the square root of 3 minus 3 squared plus 1 minus 0 squared plus 8 minus 0 squared. And that's equal to the square root of 65. Okay, let's go ahead, and you might want to pause the video here and see if you can do the next two by yourself, the y-axis and the z-axis. All right, well, if you did them, here they are. Here's my answers. To do the distance to the y-axis, I find the point that's on the y-axis that is closest to the point P, and that would be this, 0, 1, 0. And then I do 3 minus 0 squared plus 1 minus 1 squared plus 8 minus 0 squared. And so that's going to be 73, square root of 73. And then, of course, for part F, the z-axis, what's closest to this would be an 8 here. So F, square root of 3 minus 0 squared, 1 minus 0 squared, and 8 minus 8 squared. And that gives me the square root of 10. Almost done. Now I need to know the distance between that point and the origin. Here's the origin, 0, 0, 0. So now I just have to do, so this is EFG. So I'll do 3 minus 0 squared plus 1 minus 0 squared plus 8 minus 0 squared. And that gives me 65 plus 9 is 74. So the square root is 74. There you go. Well, now that we know distance, we can do all kinds of interesting things in 3 dimensions. One of the things we can do is we can think about 3 points, and those 3 points would form a triangle no matter where they are. So here's my 3 points. I'm going to call these A, B, and C. And then once we have those 3 points, we can ask interesting questions about the 3 points, like do they form a right triangle, or an isosceles triangle, or an equilateral triangle? So to answer questions like this, we have to compute the distances. In fact, that's the first part of this, but I was so excited about the triangle that I ignored that. So the first thing is to compute the distances. So AB, maybe I'll just do that distance right here. You have the points up there. So AB is 4 minus 1 squared plus 0 minus 1 squared plus 2 minus 5 squared. So what is that? 4 minus 1 is 3. So I'm going to have to put this here. 9 plus 1. And then 2 minus 5 is also 3. So that'll be another 9 when we square it. And that gives me the square root of 19 is the distance from A to B. Now the distance from A to C will be the square root of, let's see, 2 minus 1 squared plus, now we get some negative numbers, so we have to be super careful. Negative 2 minus 1 squared, and then 8 minus 5 squared. So this is going to be 1 plus 9 plus 9. Oh, that's also the square root of 19. Okay, so the distance from A to B is the same as the distance from A to C. All right, let's check about the distance from B to C. Okay, so from B to C, I do the square root of 2 minus 4 squared plus negative 2 minus 0 squared plus 8 minus 2 squared. So let's see, that makes 4. That's negative 2 squared is 4, plus another 4, plus 36. So it's not an equilateral triangle, but notice that these two sides are the same, that other one's different. So this one is isosceles. Isosceles, that's the way you spell it. Whew, okay. So we're on to spheres in the next video, but I just want to point out before we get to that video that spheres are related to distance. A circle is the set of points that are equidistant from a center. A sphere is the same thing. It's just the set of all points in 3 dimensions that are equidistant from its center. All right, so we'll do that in the next video. I know you've got a bunch of questions. Just write them down, bring them to class, send me an email. I'm happy to answer them.